So, okay, after you confirm the model parameters, binary interaction parameters here, and basically your thermal model is developed completely. Your thermal model is developed completely. And you can use the model you developed to generate the result later. Okay, later. So, for example, let's say, okay, I want to remind you that the abbreviations here, you can see the PRKBV. The PR, that stands for the Penn-Robinson, okay? The K means the Kij parameters, okay? So if there is the NRTL parameters, and then may appears in here, okay? And now you, as I said, you are able to generate the model result, okay? So let's see, where can I do this? Okay. In your panel, on the top of your panel, there is a pure binary and matrix option. So you'll see that. Okay, if we connect binary, and then you are in here. So the binary means you are going to analyze the binary system, and here is some options like TXY, DXY, TXS, TXXY, or PXXY. Okay. And since we don't, okay, so which plot would you like to choose is based on your requirement for sure. So in our test, in our lectures, we tells you to remember we tells you the phase envelope for the PXY or TXY diagram. Mm-hmm. So here we just stay with each of them, T or P, that will be fine. And TXS, that means two liquids appears. And TXXY means vapor liquid equilibrium exists, or PXXY. That stands for VLLE. So before you choose that, you'd better and you have to know what's the nature of your system. So, for example, we have already known there is no two liquid appears for the CO2 and methanol binary system. So we won't choose TXX, TXXY, or PXXY because naturally, or from our experiment, we don't observe any two liquid. So we won't estimate the system using two TXX or TXSY, PXSY. But that's based on our knowledge, and we know how these software operates. But if you choose each of them, for example TXX or TXSY, you may still have some result. You may still come up with result, okay? But that one is not supported by the data because the data shows you that no two liquids forms in this binary system, okay? So again, you have to know your system well, okay? Let's select PXY. And then you can choose component 1 or component 2 as CO2 or methanol or reverse, okay? And the result will be identical, but with different sequence. Okay, later you will see that, and it shows you the compositions that's more fraction basis or mass fraction basis, and then we want to vary the composition of CO2 and use more fraction as basis. And we start the point from 0 all the way to 1. That means if CO2 mole fraction is 0, that means the pure methanol. Okay, as it goes to 1, that's pure CO2. And then you can choose the number of intervals. Okay, for example, you can choose 100. So for each increment, that will be 0.01. That's your options. Okay. And since we want this software to analysis or to calculate the PXY, so we need to provide a temperature for the system. Okay, you can either use each of the units as the basis, Kelvin, Fahrenheit, and degrees Celsius. And you can choose the temperatures here, that will be fine. And I prefer to use the SI unit, so I use 298.15. And then, okay, for the other options, since there is no, okay, you have to see this. Despite you ask the software to calculate the PXY for you, and if you move to the calculation options, and the flash options is the valid phases. It shows you vapor, liquid, liquid. Okay, so you can choose the vapor, liquid, liquid later, but just because you know this system won't form to liquid, or it won't form vapor, liquid, liquid equilibrium. So we stay with the vapor, liquid, okay, as the validated phases. And then we return to the binary analysis and run analysis. And you end up with these results. In the plot, okay, please.
Coba lama dulu.
And please check your unit, okay, for the x and y axis. The unit, if you will see the bar as the unit. Yeah. And then there is an option here, that's called format on the top. Okay, so you can, for example, let's increase the font. Okay, there is a format on the top, so you can do some modifications on the format of this plot, such as you can, for example, I just click the legend here, and we choose font 22, and you have a big font here. And if you choose if you select the y-axis, and let's see, okay, that's not here. That's the size. Let's see if we can modify the size font. Okay, I think we can do this. Okay, so you have a large font on the y-axis or x-axis, and also the legend here. And also, if you click data here, you can increase the size. Okay, and that's your preference. Okay. So please be noted that there are a lot of dots here, and this dot is just a node. I mean, that's just if you calculate how many dots for the entire region, you end up with the value of 100. That's just because you assign your software to divide the entire region as 100 points. Okay, so the dots here does not stand for the data. Does not stand for the data. They are not data. They're just a calculation result. But the problem is there anyone who can judge the result is good or not?
Probably do experiment and
you
try
are
to
making
validate.
Data to do the comparison, right? Because 2 days ago, I got an email from one of my students that generates this kind of plot for different binary systems for sure. And then she told me that, okay, the calculation result seems weird. So she has to check what's going on behind the calculation. And my reply is, if you don't put any data on this plot, how can you judge the calculation result is weird or is correct? Right? That makes sense. So, okay. So now, after you are able to generate the plot, and then we are going to take data and put data on the plot. Okay? Are you all good with this? And then we are going to move. Okay. So, okay, let's return to the home. Okay. Home. And then there is an option here, NIST. And then you can select the property type that they are pure component property, binary nature, and ternary natures. So, because we are looking to the binary systems, so we select the binary matrix, and then you can select what are the components you want to evaluate. They are CO2 and the methane, and then you can retrieve data. Yeah, sure. Let's hear. We were in the format and try to modify the format of the plot, and then we move to the home, and then there is an option here, NIST. That's the NIST data bank. And in addition to the pure component properties and binary matrix, it allows you to take property data for ternary systems if they are available. Okay, so these demonstrations here is binary matrix, and you can just collect CO2, methanol, and then retrieve data. And it takes some time if the information is allowed.
Pegul nih. Pegul. three position.
Okay. Okay. You can see for these data bank,
Bisa minimize.
for these binary systems, they are in data like critical temperature, critical pressures, densities, axis enthalpy, viscosity, and binary diffusion coefficient, and the binary VLE 001 all the way to maybe 132. Okay. Surprise. I will let you know what surprised me. Okay, anyway. So binary VLE means vapor liquid equilibrium. Okay, the 001 means that's their tag name. Okay. So you can see if you see the binary 001, they have 6 data points. And the published year is 1947. And the temperature range is at 298 Kelvin, and which is the one we generate the model result. Okay, so probably you can okay, just double click this one. So if you double click the binary VLE01, and you can see the detail of those data points, and also the liquid mole fraction